In this video, we will talk about how to multiply exponents with different powers and different bases. So I have 4 examples for us to work through here. Let's check out this first example. Let's say we have 9 squared times 3 to the third. How can we multiply these values? Well, notice that their bases, right now, this one has a base of 9 and this one has a base of 3. Their bases are different and their powers are different. So this one has a power of 2 and this one has a power of 3. So how can we multiply these values? Well, the trick is that we either want the bases to be the same or we want the powers to be the same. So one thing we'll notice about 9 is that it has a perfect square root. So the square root of 9 is 3. So we could rewrite this 9 as 3 squared. And then we could raise that to the second power. So 9 squared, that's the same as 3 squared raised to the second power. Now, when we have a number raised to the power like this, we can simplify it by multiplying these two powers together. So 2 times 2, which is 4. So we can rewrite this as 3 to the fourth. And then we still have times 3 to the third over here. So all we've done is we've rewritten 9 to the second as 3 to the fourth. And 9 to the second, it has a value of 81. And 3 to the fourth also has a value of 81. So we haven't changed anything. We've just rewritten it in a different form. But what we'll notice is that now we have the same base. So both of these values have a base of 3. So when you have two values with the same base raised to two different exponents, all you have to do is add the two exponents together. So 3 to the fourth times 3 to the third is equal to 3 to the seventh. See, we just added 4 plus 3 to get 7. So this is our final answer, 3 to the seventh. If you wanted to, you could punch it into a calculator and you would find that it's equal to 2,187. So you could also write that as your final answer if you wanted to. All right, let's try another example. Let's say we have 4 to the seventh times 2 to the negative third. So again, we either want to get the bases to be the same value or the powers to be the same value. So in this case, we'll notice that 4, that could be rewritten as 2 squared. So let's write that 2 squared, since that's the same as 4. And then we have that value raised to the 7th power. So once again, when we have some value raised to a power and then raised to another power, we can just multiply those two powers together to simplify it. So 2 times 7, that's 14. So this is really 2 to the 14th. And what you'll find is that 4 to the 7th has the same value as 2 to the 14th. So we haven't changed the value at all. We've just rewritten it with a different base. So then we still have times 2 to the negative third. So now we'll notice that these values have the same base. They both have a base of 2. So again, when we're multiplying values with the same base, all we have to do is just add their exponents together. So we have to add 14 and negative 3, which turns out to be 11. So we can rewrite this as 2 to the 11th. And that is our final answer. And again, if you wanted to punch in 2 to the 11th into a calculator, you would find that it's equal to 2,048. So you could also write that as your final answer if you wanted to. All right, let's try another one. Let's say we have 5 to the power of negative 5 times 25 squared. How can we multiply these two together? Well, we'll notice that 25 has a perfect square root. So the square root of 25 is 5. So if we wanted to, we could rewrite this as 5 squared raised to the second power. Now, once again, when we have a value that is raised to a power and then raised to another power, we just multiply those two powers together to simplify the expression. So 2 times 2, that's 4. So this is really the same as 5 to the fourth. And again, 25 squared has the same value as 5 to the fourth. So we've just rewritten it in a different way. We haven't changed the value at all. And then over here, we still have times 5 to the negative 5. So we'll notice that now these two values have the same base. They both have a base of 5. So all we have to do is add their exponents together. So negative 5 plus 4, that's negative 1. So really this is equal to 5 to the negative 1. Now when we have a negative exponent like this is the same as 1 over that value to the positive exponent. So 5 to the first. Or in other words, we could just write 1 over 5, since 5 to the first is just 5. So this is our final answer, 1/5. All right, let's try one more example. Let's say we have 6 to the fourth times 9 squared. How can we multiply these values together? Well, we'll start by noticing that we could rewrite 9 as 3 squared. So let's do that. So let's write 3 squared, and then it's raised to the power of 2. So again, when we said we had a number raised to a power and then raised to another power, we can multiply these two values to simplify this expression. So 2 times 2, that's 4. So we can really write this as 3 to the fourth. And now over here we still have 6 to the fourth, so let's write that. 6 to the fourth times 3 to the fourth. Now this example is a little bit different because the bases are still different, but we'll notice the powers are the same. So 4 and 4, they have the same power. So when you have two numbers raised to the same power like this, you can simplify it by writing the bases multiplied by each other. So we can say 6 times 3 raised to whatever the power is that they have in common, which is 4. So that's how we can simplify this expression. So 6 times 3, that's 18. So we can write 18 to the fourth power. So that is our final answer. And if you wanted to, you could punch that into a calculator and you would find that it's equal to 104,976. So you could also write that as your final answer. So those were just a few different examples of how to multiply exponents with different powers and different bases.